a very interesting problem. The problem is that if the midpoints of the sides of a given square are connected with each other, we can get again a square. And if we continue this process endlessly, we can find the infinite number of squares. Here we find out the sum of the areas of this infinite number of square, which is constructed by connecting the midpoints of the squares, midpoints of the sides of the square. Now, to solve this problem, we first draw a square. This is the given square. Its side length, the length of the side is A. A be the length of the side, length of the given square, length of the side of the given square. Now, if we connect the midpoints of the sides of this square, again we can get a square. Further, if we connect the midpoint of the sides of the first constructed square, again we can get a square. And if we continue this process endlessly, we can get infinite number of squares. Our aim is to find out the areas of this infinite number of squares. Now, we have already known that the relation between length of the diagonal and length of the side of a square. The relation is that the length of the diagonal is equal to the √2 times the length of the sides of the square. Here, the length of the diagonal is how much is the diagonal is A into √2. So the side of the first constructed square first constructed square is half of the length of the diagonal of the given square, that is A by √2 by 2 equal to A by √2. So, the diagonal of the first constructed square equal to A by √2 into √2, that is A. Side length of the second constructed square is half of the length of the diagonal of the first constructed square. Side of the second constructed square equal to a divided by 2. Diagonal of the second equal to a by 2 into root 2, that is a by root 2. So the side of the third constructed square equal to a by root 2 into 2, and so on. In this similar manner, we can find out the length of the side of the fourth square, fifth square, sixth square, and etc. Side of the fourth square equal to a by 2 root 2 into root 2, that is a by 4, and so on. Now we shall find out the sum of the areas of this infinite number of squares. Let S be the sum of the square, sum of the areas of this square. So S equal to area of the first square. Area of the first square is side of the first square is a by root 2, that is a by root 2 square. Area of the second square, second constructed square is the side of the second square is a by 2 the square, a by 2 the square, a by 2 square. Area of the third square is a by 2 root 2 square. Area of the fourth square is a divided by 4 square, and so on. Now we see this series is the infinite series and also infinite geometric series. We have already known the sum of the infinite geometric series. Sum of the infinite geometric series is equal to the first term of the series divided by 1 minus common ratio. Here first term is a by root 2 a by root 2 plus a by root 2 square a by root 2 square divided by 1 minus common ratio. Common ratio is half, that is a square by 2 divided by 1 by 2 equal to a square. So in this way we have found out the sum of the areas of the infinite number of squares, and the sum is equal to the area of the given square. So if we connect the midpoints of the sides of a square and continue this process endlessly, we can get infinite number of squares, and the sum of the infinite number of squares is also the area of the given square, that is equal to the area of the given square.